Okay, this is 1.4a in college algebra, equations of lines and modeling. First thing we're going to discuss here, and again, we're basically still into review because we're doing slope-intercept form and that kind of thing. All right, so that's the first thing we're going to look at, slope-intercept equations of a line. If we have an equation in slope-intercept form, then it's real easy for us to graph that line. So when the equation is not in slope-intercept form, we have to get it that way, because if you remember, last lesson or a couple lessons ago, I said the only way you can graph these lines quickly and easily, these linear equation lines, is if you know the slope and if you know the y-intercept. Because if you know the y-intercept, which is right here, and its sign, if we know where it crosses the y-axis, then that's one of the 2 points in order to graph this. Then we have a slope right there. And the slope, if we write it as a fraction, is 3 over 1, and that's y over x. So that means we start at this point right there, and we go 3 up or down because it's y, 1 left or right because it's x. So because they're both positive, we're going to go up 3 over 1. Second point. Up 3 over 1. There's another point. Or we could go down 3 over 1 like that, because 3 over 1 is the same as negative 3 over negative 1. And then we draw our line through all of our points, and we have the graph of that equation. So you find the y-intercept, and you find the slope, and you can graph any of these linear equations. All right. Sometimes they will give you information such as example number 2, and they will tell you to find the slope and the y-intercept of the line with the equation 3x minus 6y minus 7 equals 0. So in order to find the slope and the y-intercept, we have to write it in this form. This being just a number, m being a number, and x and y being left as x and y. So let's go ahead and move things around. All right, so we only have a y on one side of the equal sign, so we'll move everything else to the other side. Divide by negative 6, and we have y equals negative 3x over negative 6 plus 7 over negative 6, because we can split those up. And we end up with y equals 2 negatives, give me a positive. 1/2, let's write it this way, since we're putting it in slope-intercept form. Negative 3 over negative 6 is 1/2, and negative 7 over 6. So what does that tell me? It crosses the y-axis at negative 7 over 6, which is a little lower than 1. Whoops, that's a little bit too low, isn't it? Alright, let's get a better blue here. That's an ugly blue. Okay. And then when we go up 1/2 over 2. Up 1/2 over 2. So up 1/2 would be around like that over here. So you're just kind of guessing with these, and so you're getting a graph that kind of looks like that when all is said and done. Okay? So that takes us to example number 3. And example number 3 says we've got a line that has a slope of negative 7/9 and a y-intercept of 0.16. So it crosses y at 16, and the 0 just means we went left or right, 0. So we know it's on the y-axis. Find the equation. All right, so we're putting it in this form. All right, so do we know the y-intercept? The y-intercept is where it crosses the y-axis at 16, and we know the slope, and that's all we need. And we're done. Okay? All right, example number 4, and as we go, they get progressively a little more challenging, but hopefully you're not running into any major challenges yet. So a line has a slope of negative 2/3 and contains the point negative 3, 6, meaning that we've got a line that is at a certain angle, negative 2/3. So we know it goes downhill from left to right. Okay, and it goes through this point. So we know that that line, as it's going downhill, is going to go through that point right there. Okay, so what we're supposed to do here is find the equation of the line. Okay, what did I say we have to know? We have to know the slope. We have to know the y-intercept in order to graph this. Okay, we know the slope, but we don't know the y-intercept. So what do? We take what we do know, and we're going to put a negative 2/3 in for our slope. We don't know the b, but we know an x and a y, right? That's what these are. So our y is a 6, and that equals negative 2/3 times negative 3. And look what we have. We have one variable in this one equation. So 6 equals 6 over thirds plus, or 3 over b plus b. So we have 4 equals b when we're done. So our equation is y equals negative 2/3 x plus 4. All right, so what we did here is we took the information we were given, an x and a y and an m, and found b. Once we found b to be 4, then we could write our y equals mx plus b. And remember, what you need for this form of the equation is you need a slope and you need a y-intercept. These x's and y's turn back to x's and y's. They always do. When you're writing an equation, all you replace the slope with, or the m, is a number, and the y-intercept with a number. The x and the y stay as they are. Okay. And that takes us to example 5. Graph y equals negative 2/3 x plus 4. So they want us to graph that. This is the answer to the last problem. All right, easy enough because we know where the y-intercept is. It's at 4. And remember what I said before as far as slope. Slope equals y over x, which is negative 2 over 3. Now, how do I know the negative is on the 2 and not the 3? It doesn't matter. It can go on the 2 or on the 3, and I'll show you in a minute. Let's do the negative 2, 3. So that means the y is negative 2 and the x is 3. So we start at our y-intercept, and it says we go up or down 2. And because it's negative, we go down 2. And the x value is 3, so we go over 3. So we have a point right there. Okay, so all we're trying to do is graph this. Okay, so we can graph it then just like that. Now, what if we said that the 3 was negative instead of the 2? So it's still y over x. So that means we go up 2 this time. So we're going to start here at our y-axis, go up 2, and over negative 3. So up 2 over 1, 2, 3. And see, we have a different point than we had here, but the point is still on the line, which means we can still draw the exact same line. It's just that we're drawing it through this point and this point now instead of this point and this point. So it doesn't matter because the line is going to be the exact same line. All right, so that jumps us up to point-slope equations of a line. And we're cruising through here pretty good. Makes it kind of nice because you're not asking any questions and I can just keep talking. Point-slope equation of a line. All right, so we have the slope-intercept form. And then we have the point-slope equation. The point-slope equation is 1y minus another y equals slope times 1x minus another x. Okay, so these are very similar, and a lot of times you can use either or. You don't have to pick which one you're going to use. So, for example, in example 6, they give you 2 points, 0.23, and they also give me 0.1, negative 4. All right, so if we're using the slope-intercept form of the equation, we have to eventually find out what the m is and what the b is. Okay, so let's go ahead and solve for our m and our b given just these 2 points, because let's graph those 2 points just so that you know what the line looks like. 1, negative 4. So the line basically looks like this. It has a positive slope. It goes uphill from left to right. So that's the line that we're trying to define here. Okay? And almost always you're going to be trying to find the slope first. So if you remember, the slope is this. So we have two values here, 2y's and 2x's here. So let's take the 3 minus negative 4, subtract our y's there, and 2 minus 1. So this gives me a 7, this gives me a 1, so our slope is 7. Okay, easy enough. Now, I can take my slope-intercept form, y equals mx plus b. Alright, I already found the slope here, so I can erase m, and I'm going to put a 7 in there. Now I have to find b. Well, how can I find a b? Well, I have two x and y's. I've got a 2 and a 3 there, and a 1 and negative 4 there. An x and a y, an x and a y. I'm just going to replace this x and this y with these x's and y's. So which one do I pick? Do I use the 2 as the x and the 3 as the y, or the 1 as the x and the negative 4 as the y? Doesn't matter. You're going to get the same answer no matter what. So let's take the first one since it didn't have any negatives. So I'll put a 3 in there for y and a 2 in there for x so I can find my b. Okay, so I find out my b is negative 11. So now I have y equals, my slope is what? 7x minus 11. So it's mx plus b, but since my b was a negative, it becomes basically mx plus negative 11, or just negative 11. So there's my equation that I was looking for. Now if I'm going to use this other method that I have up there, the point slope equation method, so let's use this method right there. So remember, I'm looking for an equation. Equation is going to have variables in it. So I'm not going to just put a 2 in for one of the x's, a 3 in for the other x, a 2 for an x, a 3 for a y, a 1 for an x, a negative 4 for a y. I'm just going to pick one of these. So let's pick this one again. I'm going to write it as y minus one of the y there equals the slope we found would be 7 times one of the x's minus 2. Okay, so what do we find here? Y minus 3 equals 7x minus 14. Add 3, add 3. Y equals 7x minus 11. So there's my other equation. So don't take both of these x's, 2 and 1, and plug them in, 2 and 1, and the y values, 3 and negative 4, 3, negative 4. Don't do that. Just take this equation and take the x and put it here, the y and put it here, or take this equation and take the 1 and put it there, and the negative 4 and put it there. Leave the y and the x as variables. Just substitute one of these sets of numbers for the y1 and the x1. Okay, so that's a key thing there, because if you don't, you're just going to get a 1y value, 3 minus negative 4, and get 7 equals 7 times 2 minus 1. So what you're going to get, let's just go ahead and put that on there real quick. Okay, so see what I did? I put in for the y minus y there, the slope times x minus x. Let's see what happens. 3 plus 4 is 7 equals 7 times 2 minus 1, and you get a true statement there. But you don't get an equation. You just said that that's a true statement. We already know that's a true statement. We want the equation, so that's why we only substitute one set of numbers in there. So that's it for 1.4a. We'll start on 1.4b in just a second.